Now, we need to bring stoichiometry to a conclusion. And to do that, I must remind you again that everybody needs to be very familiar with the mole. Are you okay? If you were given atoms, molecules, or ions, could you go to moles? If you were given grams, can you go to moles? If you were given litres of a gas, could you go to moles? Now, please go back if you're not sure of that. Is very, very important. I'm going to continue with the stoichiometry then. And it's very important for all of you that you know where we are in this section. Now, here you go. Take a look, please. Very important. I'm down at number 5, okay? You have a copy of this now. I'm down at number 5. I'm calling this reacting masses, okay? And basically, we will be using it. You'll be given a full balance chemical equation. And the idea, of course, will be that you can use it in all sorts of calculations throughout an exam paper. I'll be doing number 5 in the course of this particular section, all right? And we call it reacting masses. I'm presuming now at this stage you've dealt with down to number 4, and this stands alone. By the way, the last 3 here, I'll be telling you in the next section that you need excess reagent. I'll be telling you that. You'll need excess reagent, okay? And it's very important that they are units in themselves. They are likely to get you quite significant marks at the bottom of this. And I'd ask you to work with it. If you will, you'll do fine. To calculate reacting masses then, using the limiting reagent and a balanced equation. I'll talk my way through that now, and we'll see what has to be done with it. I think you'll find there'll be issues here that we'll deal with. Now, you'll be given a full balanced chemical equation, and you'll be given one quantity. Now, here we go. I'm giving you an equation here, okay? I'm giving you that. Reacting masses there, I'm giving you that. Okay, and they'll introduce that in the paper, they'll herald it in with some kind of a speech as to what the content is, and you'll deal with it like that. And there'll be no issue at all with it. You'll be expected in this instance to do it right, and I hope that it will work out for you, right? So, you'll be given that equation, and they'll make some kind of statement along the following lines. Chlorine gas is prepared in the lab by reacting manganese 4 oxide with hydrochloric acid according to the following equation. And they'll give you this equation, right? You're given a full balanced chemical equation. And they'll give you one quantity to go with it. So whenever they give you a full balanced chemical equation and one quantity, will you take it please that one quantity, that singular quantity, will you take it please immediately, a singular quantity is the limiting reagent. I'll talk to you more about it in a moment, okay? So they give me that, so you'll transpose that onto your manuscript. Now, you have notes on this, and can I remind you please that equation is given to you in your notes, and they gave you the mass as well, okay? You have manganese 4 oxide, you have HCl, there's 4 of them there, and it goes to manganese chloride, and it goes to chlorine, and it goes to 2H2O. And you have, of course, now be very careful you take it down correctly, will you please? You have 1, you have 4, you have 1, you have 1, and you have 2. Is that okay? And it's very important you can read that. Can I just check that you're all getting that on camera? It will be very important that you're all picking up the image on that. You are. That's fine. Now, sorry, it's important you can read this and you can see where we're going. Now, they'll say to you in the course of the thing that 4.35 grams of manganese 4 oxide were reacted with hydrochloric acid and produced chlorine gas according to the following equation. So you're given a full balanced chemical equation and you're given one quantity called the limiting reagent. And it is very important for you now to recognize this, that if you're given that, then you can construct the mole strip. Okay, the mole strip. Now, that's an Ernieism, by the way, I just made it up, okay? That's what you do, but you set up a mole strip and you'll answer all your questions based on the mole strip. Now, I hope this will be okay for you. I'm going to deal with it now for you, okay? As follows, then, here's the mole strip. It's in your notes. We might need to tidy it up a bit. The ratio strip you put in for a start, that's, to be nice now if the equation was down correctly, 1 to 4, 1 to 1 to 2. Okay, make sure you have that 1 to 4, 1 to 1 to 2. Very good. And now the moles. I'm going to make a little table out of it. That can be useful because you'll segment each section then. Moles as follows. That goes to there. So you'll have to divide that. Are you all okay? You'll divide that by the MR for that. Okay? And I'm looking it up for you here. It's 87. Divide that by 87 and you're going to get 0.05. 0.05 moles. Yes, 0.05 moles. Right in there. 4.35 divided by 87. Okay, will you take it please? That gives you 0.05. Why am I saying this to you? They invariably cook that particular figure. They adjust it when they're setting the paper so that you get a nice rounded figure here. Keep that in mind when you're doing calculations in Leaving Cert. You know that the figure will be rounded. You'll know you're right. If you're getting a dodgy figure there, 3 or 4 decimal places, take it you probably have slipped up somewhere with your thing. Sometimes when you use the data from the periodic table, this doesn't come out to be exactly 87. Okay, in house exams. But in the Leaving Cert, those figures will be given on the front of the paper, so you'll be getting them from there. That'll be fine, okay? And it comes out as that. That's that one. That's 4 times that you completed then, okay? That's 0.20. That's 0.05. That's 0.05. And that's 0.10. And there's your mole strip. You now have completed the mole strip. And now you're asking the question, well, what would you like to answer? Anything they'll ask you, you can answer based on that. You can do anything with the mole strip, right? So there you have it. That's the limiting reagent now. Very important. I better write that word up here. Limiting reagent. Do you know what that means? It's practically self-explanatory if you think about it. It means that this reagent limits how much product you're going to get. Or, to put it another way, when that runs out, the reaction stops. So that ultimately runs out, and we all know that from doing various things in the lab. You have a test tube and it's fizzing away for you, and suddenly it goes dead on you after 5 minutes, and you say there's nothing happening here. And we understand that, okay? We say the stuff ran out, and that's right. The limiting reagent ran out. The other one didn't, by the way. Once one of them runs out, then it controls how much product you can get. And that's very important here that you work your way through that. So that's very good. And there you are. That's your mole strip. Now you can answer anything you're asked on it. Let me give you some idea about it. Okay, they might ask you, what volume of gas is produced? Produced. That's the only gas. Now it will be marked as a G in the exam. So you take that many moles and you multiply it by 24.0 litres of Cl2. Very good. And they might ask you, how many molecules of water are produced? There's the water, there's the number of moles, and it's 0.10 by 6 by 10 to the power of 23, and that's molecules of water. And they might ask you, what mass of salt is produced? Now be careful, your language here is very important. Produced means it's on the right-hand side. That's not a salt, that's not a salt, so that's the salt. Okay, I mean, you work on that basis. You may not have seen the equation before. So you take that, 0.05 moles, and you multiply by the MR for that. The relative, like 1 manganese and 2 chlorines, and that will be your answer in grams. Very good. And that's one of them. You're okay with that? So you're given a full balanced chemical equation, and you're given one quantity called the limiting reagent that allows you to set up the mole strip. That's one. There's a second one then. I'm using these just as exemplars. There's another balanced chemical equation for you now. And we must go through this one. And I hope it's okay. So I scrub that and we put in the next one. Okay? And you're constructing your mole strip each time. Now, we're going to, in the next unit, we're going to use quite a few exam questions to see how you'd handle this. So it's important you have a good method. The copper reacts with HNO3 nitric acid. And it's going to give you copper nitrate, NO3 twice. You don't need to know any of these chemicals now to work on this. You're just taking down what you're given. You have NO2 and you have H2O. I've deliberately left out some numbers now for a moment because I want you to realize it's crucial that you get the balancing numbers right. There's a 4 here. Okay, there's a 1 there. We don't write ones. There's a 2 there, and there's a 2 there. Everybody okay with that? And they've told you in the question, they'll have told you this, that they used 25.4 grams of copper. 25.4 grams of copper, okay? Now, to read something along the following lines. Nitrogen dioxide is a brown gas. It can be generated in the lab or produced in the lab by reacting concentrated nitric acid with copper filings according to the following equation. And then they'd say something like, when this gas was prepared, 25.4 grams of copper were used. Calculate 1, 2, 3, and 4. A series of questions going with it. So we must construct the mole. You're given a full balanced chemical equation and you're given only one quantity, so that must be the limiting reagent. Would it bother you if that was printed there and that was printed there? I hope not. That's very important, right? That you have a sense of that. So basically we set up the mole strip then. Here's the ratio strip. It's 1 to 4 to 1 to 2 to 2. And this is moles as follows. You convert that to moles, okay? And you divide that, you know what you're doing? Divided by the AR for copper. You're divided by 25.4 divided by 63.5, he says, chancing his arm. And I'm getting 0.04. 0.04. So be very careful with your figures now, please. No, that's 0.4. It is 0.4. Sorry, excuse me. 0.4. Will you be careful? Okay, 0.4. Right? So all the rest will be the same. That will be 1.6 when we're working through that. Are you all okay with that? 0.4. So you have 0.4, so you're going to have 1.6, 0.4, 0.8, and 0.8. Okay, so you have the mole strip finished. Very good. And now you can answer any question you're asked on it. Now, can I give you a health warning, please, about the mole strip? If you get that number wrong, then there's a sad story to follow. Because all of these will be wrong, and you can see you lose a lot of marks very quickly. Please be careful, take your time. Now don't cut out don't go any shortcuts on that now at all, please. And put in that loop in your notes, please, will you? And link that to that. And we call that the mole strip, all right? Now they'd ask you questions like, what mass, what volume of gas is produced? There you go. That many moles, 0.8 multiplied by 24.0 litres. If they said STP, that'd be 22.4, yeah? Be careful, please. Litres of NO2, be careful, okay? They might ask you how many molecules of water, multiply that by Avogadro's number. What mass of copper nitrate? You take that and multiply by the MR for that. Be careful, there's a 2 there. Okay, when you're getting the MR, be careful. And that's effectively what you're after. Are you okay with that? That's basically what that's about. There's nothing in that, and you'll find it good. Okay, there'll be no issue there. Now, let me show you a question that came up in Leaving Cert that created a lot of problems for a lot of candidates. And I like to do that with you because it does that, okay? This particularly caught my attention. It was messed up by a lot of people in Leaving Cert, okay? Now, I go back on this. I'm just telling you from the marking scheme point of view that you need to be careful. Now, you've nothing to take down. Just listen to this and see how you're making sense of it now. Have you a method? They would give you an introductory speech on that. I hope you're all okay with that. They will make statements about it and they'll tell you about it. Something along the lines now, chlorine gas can be prepared in the lab by reacting potassium manganate 7 with concentrated hydrochloric acid, which is in excess. They'll make statements like that, but don't worry about it. They'll end up giving you a full balanced chemical equation. They often give you a little speech at the beginning, like chlorine gas is very dangerous if inhaled. It was used as a chemical weapon in the First World War, and distractions like that. But they give you that to put it in context. It has nothing to do with the question. Okay, and they give you a full balanced chemical equation, and they give you one quantity. They said that the KMnO4 reacted with an excess of HCl. The excess means the quantity doesn't matter. There's loads of it there. You have more than you need. That'll come up in the next section. Don't worry about it. So you have a full balanced chemical equation here, and you have 3.95 grams of that. And so you'll have to set up a mole strip for that. Are you okay? And that's what I'm going to do now. You'll see where I'm at. Okay, just watch this now. And there's my mole strip. Now, I'm doing this one deliberately because there was a lot of errors made by a lot of candidates with this, and you must avoid these errors now. Once you know what you're doing, you won't make those errors. You need a structure in place. So here we go then. I have the ratio strip here. Now, can I tell you, please, that I've done something deliberate here, and I want you to be aware of it too. The ratio strip is very important, right? If you were writing out the ratio strip there, I'd recommend you'd write it twice, okay? That the ratios would come out as... I have them there as 1, 8, okay? They'd come out as 2, 16, 2, 2, 8, and 5. Now, I find it useful if the limiting reagent could be unity, because then everything is a multiple of that. Are you okay with that? Everything is a multiple of it. It's a good idea. Now, to avoid error, now I'm saying to you, please, everybody, would you write the ratio strip twice? Okay, there's no problem with that. And so the ratio again is 1, 8, 1, 1, 4, and 2.5. Now, I'm saying that to you because there was shocking errors made here. Now, I don't know what it has to do. It has something to do with maths, I suspect. But please, always keep it as simple as possible for yourself, and you won't have any issues. And that's what you're after, okay? And that's what we're working with. There'll be no issue there. All right, so you're working your way through that. You can see what I've got there. And now you must convert that into moles. Everybody okay? You divide that by the MR for K, MnO4. 1 potassium, 1 manganese, and 4 oxygens. Divide that into that, and you get that many moles. That's a multiple of that. There you are, there you are, there you are, there you are, and you have moles. Now please, that one would easily go wrong on you if you hadn't adjusted there first day. You see, you're looking at 2/5, okay? Will you be careful to ratio 2 to 5, okay? It's a good idea to do that and put moles in next then. Okay, so you get the quantity down here, which is the limiting reagent, and everything is a multiple of that. And there you are. Now, that wasn't the worst of it. Having that. Now, I find most people do this question, they don't use a mole strip of any kind. They just take each as an individual question. I don't think that's a good idea. The overall plan of picking out the piece you want and getting the answer. So it's important to get everything right here. You could take all the marks out of this with any bit of care. First thing they asked you was, how many moles of hydrochloric acid were consumed in the reaction? And there's your answer. Okay, straight from the mole strip. How many moles of hydrochloric acid were consumed in the reaction? There's your answer. Next, nearly everybody made a mistake with this. Calculate the total number of moles, calculate the total mass of chlorides produced. The total mass of chlorides produced in the reaction. Now folks, that begs a very important question. What is a chloride? And of course, I must deal with the bit that IDE, a chloride, is something with 2 elements in it. There is sodium oxide. Okay, sodium oxide. There is sodium chloride. Okay, oxides, hydrides, nitrides, anything ending in IDE is only 2 elements, whereas something ending in ATE has 3 elements. Okay, sodium sulfate. Okay, that's sodium, sulfur, and H. ATE will have a 3rd element in it, where there's only 2 elements if it's ide. So they asked you for the chlorides there. So some people, total mass of chloride, some people saw that chloride, took that many moles and converted it to grams and gave that as the answer. That was not correct. Some people saw that chloride, took that many moles and gave the answer in grams, and that was not correct. And some people saw that chloride, took that many moles and got the answer in grams. Now you know what I'm saying to you, all of them are wrong. Okay, the fact of the matter is that's not a chloride at all, that's an element. Okay, so that wasn't involved at all. There's 2 chlorides here, so the answer is here, that you must get the 2 of them right. And there you go. Are you okay, everybody? KCl, 0.025 multiplied by 74.5 gives you that many grams. And there's the other one, both coming out now of the mole strip, please. Both coming out of the mole strip, okay? Different MRs, please tag them. I'm not obeying my own rule here now, but I should be tagging them. And that one there is grams of all the chlorides that are produced. A lot of errors in that, be careful with it, please. The next one, how many water molecules are produced? So you go to the water, there's the moles. Okay, there's the moles multiplied by Avogadro's number, no bother there. And what volume of chlorine gas? Again, you go to chlorine gas, there it is, and that number was wrong by a lot of people now. Just saying that to you, that was wrong. Will you be careful, please, when you're dealing with that, okay? I did that deliberately to try and eliminate that error, 2.5 times that. And that many moles by 22.4, it did say STP, okay, be careful. Okay, and that's 1.4 litres, decimeters cubed. Litres is probably what you write, and that's fine. How many atoms of chlorine are in this amount? And of course, this amount is the same number of moles, multiplied by Avogadro's number, and you get molecules of chlorine. Please say that and tag it. Every molecule has 2 atoms, so you must multiply by 2, and that's what you get there. That's very important that you're getting that right. Now, that's a very important section. Okay, in the next unit now, we're going to do exam questions on this. And it's very important for you to realize that you must prepare this before you start looking at exam questions. If you do, you'll find that you'll get a lot of reward from this. That's about 25 marks now. And I'd like to think you'll follow that up, okay?